All right, so we're going to take a look at a method of factorization that's called prime factorization. Now, this is a method of trying to break down a number into smaller and smaller values, okay, which all multiply together to come up with the original number. So, prime factorization. Now, if you can't read my writing there, you can always look right here. Okay, there's prime factorization. Is factoring a natural number, okay, natural meaning a value bigger than 0. Okay, so it's just a regular number bigger than 0, so like 1, 2, 3, 4, no decimals, no fractions and such like that, into a series, and definitely of primes. Sorry, of prime numbers. Okay, so trying to be able to multiply those numbers up into our regular one there. Okay, so the product of these prime factors will give that natural number. So now we can use it for small numbers as well, but I want to take a look at how do we do a large number as such, and I want to give you a couple different methods that you can use. One of them is what we call the tree method. One of them would be what we call the prime division method. So the tree method, what we're going to do is we're going to take this value here and we're going to try to divide it by something that's decently large. Okay, something that we know can definitely go into there. And if you look at 3,300, okay, so this is something where we can multiply it, or we can divide it by 100 because it is divisible by 100. So that means that 3,300 could be a product of 33 times 100. And I'm going to use a little, I should use a little dot there, not the multiplying sign here, not an X. So it can be, broken down into 33 times 100. Now, when we look at each one of these numbers, we can break them down a little bit farther as well. 33 can be broken down into 3 times 11. And 100 can be broken down into, there's different ways of doing it, but let's do 25 times 4. Okay, so that's a way of breaking it down a little farther. So 3,300 could be like 3 times 11 times 25 times 4. Now, we want to keep going until we can't break these numbers down any farther. So the 3, well, that one we can't break down any farther, so we're going to leave it at that. 11 is also a prime number, so we can't break that one down any farther. 25 is not a prime, but we can break that down into 5 times 5. And 4 we can break down into 2 times 2. So we're just continuing to break it down as far as we can. And this is what we call prime factorization. So 3,300 could be written as 3 times 11 times 5 times 5 times 2 times 2. Now, if you want to double check, I got a calculator here for just for that reason. 3 times 11 times 5 times 5 times 2 times 2 gives us 3,300. What we've done is now we've broken it into a series of primes. Okay, these are all prime numbers. So this will be our answer right there. Okay, 3 times 11 times 5 times 5 times 2 times 2. Now, there is another method, and I call this the prime division method, and I have another name for it, and I'll tell you that one in a little bit once we've finished it, kind of because we've got to see it once it's finished. But another one here is prime division method, where we only try to divide by primes. Okay, and so if you're trying to figure out what primes are, remember we go back to here, these are prime numbers. Okay, and so we want to try to divide by these numbers right here, and my suggestion would be starting with the smallest numbers possible, or going to a number that you definitely know works. So 3,300 here is an even number, so we can divide it by 2. So we're going to divide it by 2, and when we do that, okay, and I'm going to use calculator here, 3,300 divided by 2, we get 1,650. Okay, so 2 times 1,650 would give us 3,300. Now, just like we did here in the tree method, we're looking for prime numbers, and we've got one, but this one's not a prime yet. Okay, and we got to keep going until we get a prime. And so here we're going to break down. We're not going to worry about the 2 anymore. We're just going to leave that because it's a prime number, but we're going to worry about this one here. And I still have it on my calculator, and I got to find another prime that can be that 1,650 is divisible by, and that's going to be 2 again. There we go. That works. Good. So 2 times 825. All right, again, I got a prime number and I got a not prime number. Okay, so what we're looking for is a prime number and a not prime number. Well, 825 is not a prime number. Okay, anybody have an idea of what we can divide it by? We can divide it by 5. Let's do that. Okay, so we're going to divide it by 5. And we're going to keep breaking this down. 5 times 165. Okay, again, 5 is prime. 165 is not. We can also then break down 165 again. We can divide that one by 5 also. That works. Okay. Now again, the order that you do this in doesn't really matter, as we're always just going to look for the prime number. So you could start with 5, you could start with 11, because you know that one works, but we can kind of keep going on and on from there. We get 5 times 33 gives us 165. 33 still is not prime. We can divide that one by 3, and we get 3 times 11. 11 is prime. And so what we have here is this string of numbers, and we're going to use that last one as well. Okay, and now I told you I had a different name for it. I call it the hockey stick method. And you might be able to notice it looks a little bit like a hockey stick. Yeah, so that is another method that we can use to factor, and I'll show you this in a bit simpler form when we get to the examples.